What we wanted to cover today was a demonstration of a particular module of AssetAsyst, and it's the Bridges module. Just to show you the agenda for today. Yeah, so with the agenda, we'll just go through a brief introduction of who's presenting. Obviously, I want to cover the topics for today, which we've laid out just to be covered over a 1 hour period. So we're looking at the whole life cycle of managing bridge and culvert assets. So just by way of introduction, obviously there's myself, Andrew Sonnenberg. So I'm National Bridge Engineering Manager for pitt&sherry, but also the Product Manager for AssetAsyst. And today we also have online Adam Collins and Hamish Murphy, both software engineers. So Adam's going to be stepping through the examples we'll cover today about how AssetAsyst works, and Hamish will point out one of the new modifications we've just made to one part of the software with respect to bridges. Like always, for existing clients, if you've got any questions or want training and support, don't hesitate to call us, and we'll organise a training session for you in particular. So I think without further ado, we'll just go through the next slide to just summarise what we're covering. So we'll start off at the phase of the project where you've got a new bridge and you want to manage that, bridge or culvert, and how you get that into AssetAsyst. And then we'll work our way through inspection of the asset, reporting on it, how you can schedule repairs, and then ultimately replacement. So the whole life cycle. Creating an asset, we will just go through, and I think at this stage, Adam, if you want to take us through to AssetAsyst and do a demonstration of adding an asset, that would be great.
Yeah, so we've got a number of pre-existing structure assets that we've created in here. So I'll open up this breakwater bridge. Now we have a number of different methodologies that we support, and you'll see as we go through these different bridges that this one here is a VicRoads bridge. Now you can see this initial tab here shows you all the generic data. This is asset level data. We also support custom fields. We haven't defined any at the moment, but you can create whatever fields you want. We define all the units on an asset. So again, these are using the VicRoads standard codes, 1P22C and so forth. We've got attachments. So on this bridge, we've just put a few in. We have a western view, we've got a cross section, a piling photo. We have tabs where you can display all the defects and inspections that are related to an asset. We also have some load rating information here, which you can make use of. There is a financial tab, and you'll see here we have the current and replacement costs that have been set for this structure. The distinction here is you may have a structure that's of one type and you may want to replace it with a different type of structure. So you can use the current and replacement structure classes to define two distinct values there. And we also historically store some information as it has changed. So you can look back over the history of the asset and you can see that these values were changed at a certain point in time, which can be useful for auditing your data.
Yeah, and Adam, if I guess you just want to show briefly, I just put in something for the Sydney Harbour Bridge there as well. Just to show how the software supports not only the VicRoads inspection system, but the Roads and Maritime Services inspection system in New South Wales. And so the difference there is if we go to the Units tab, we find that the actual units there have got codes of, see down the bottom, the wearing surface called a MWES by Roads and Maritime Services. So the software fully supports that. And if we went to another type of structure elsewhere in the country, say the Sandy Corner Bridge, I just put in there because it's a bridge that we had designed recently for transport and main roads in Queensland. Again, and if we look at the Units tab there, we'll see a slightly different convention. I haven't added something in, but if we went to add in a component, we'll get a component listing which is as per the TMR inspection manual. So what we might do now, Adam, shall we add in a bridge for, say, Vic Roads methodology?
Sure.
And the other thing you might have noticed in that asset tree we're looking at, because we support all types of assets, you would have seen there's things such as noise walls, buildings, roads, etc., that can be entered into the system as well. So it'll handle any type of asset. But today's presentation, the focus is just on the bridges and culvert side of things.
So yeah, to create a new asset, just go into the File menu and you choose New Asset. Now, in this case, we want to create a structure asset, which is used to cater for our our bridges, culverts, and marine structures. We're just going to call this example bridge, and we use the Big Road Structures methodology, and this one is going to be a bridge. We'll also choose a maintenance category, which will pre-fill our inspection schedules for us.
Yeah, and so even though it's pre-filled it at a later date, you can actually, for each structure, have a different inspection frequency and due dates if you want. The reason why we've created that on a standard format, often people in their asset management plans will state that they want a particular frequency, so by default it'll join in with that.
So I'm just going to fill in some details on this structure.
Yeah, so you could put these drop-down lists here in the Tools menu. You can customise to suit in whatever way you want. In this database, just as a sample database, we've just pre-populated with some standard sorts of options we find useful. As Adam's demonstrating there, we've gone the structures over water. This one's going to be for a road. Have you got some photos just on your drive you could show, Adam, so people can sort of get a picture for what we're planning on entering here? Well, we could attach them now. So if attaching the items, you can either go through the File menu, as Adam's showing there, or you can drag and drop onto that area from your desktop or any drive that you have on the network.
Now, those of you who have seen AssetAsyst or BridgeAsyst before will notice that we have enhanced this geometry section from the way that used to work. And I might let Hamish talk into that a little bit as I fill these numbers in.
Yeah, so we changed the geometry inside the application so that before you had a fixed number of fields that you could enter in. So you could have up to 2 widenings, 2 lengthenings, and an original structure. We wanted to change that so it's more flexible. So what we've done is we've made it so that you can add any modification that you want. So it gives us 2 advantages. One is as well as adding as many widenings and lengthenings as we want to, we can also add a raising or a redecking. And the second benefit that gives us is with the Inspector app. The Inspector app has been able to capture that information for some time, but this brings the application in line with the Inspector app. So you can go out into the field, you can do a raising, for instance, and it will be imported from the device into the application.
Yeah, thanks for that, Hamish. And I guess where we came from the original Vic Roads inspection manual, which has a paper-based form, and we displayed the data previously in that way. And what we'd found is that it was very limiting, and therefore, yeah, the need to update it. Also, this data with the year of construction flows through to the Units tab and helps populate information there, which is later used for the predictive modelling. So it streamlines the whole process to minimise the amount of work an end user needs to do going on from once they've collected some basic data from the level 2 inspection process. So what Adam's done, he's entered in, while we've been talking, the generic data for the structure. Now he's going through the pick list and adding some components to the structure. And so in this case, he's representing a bridge structure because he put in components for a stringer there.
So we support a number of inspection methodologies in the software, and these methodologies define a number of things, such as the frequency of inspections, as you saw, the way the components are named, the way we define the location of components on the structure, the defect types, and the repair items.
Excuse me, Adam, there's a question.
Mm-hmm.
Is locability maintained, e.g. change of suburb name chainage?
Some of the fields, yeah, we do store historically as they change over time. The chainage is not one of those fields. I believe the suburb might be, but it would not be difficult to add that in if anyone thought that was useful. Then yes, we can add chainage into that history tracking as well.
Yeah, so at the moment under the generics tab, you link to a road, and on that road it understands from the chainage you put in where the structure is and what towns it might be between. Or if you're a rail asset owner, it will understand what key points on your rail network you're between.
Yeah, so of the methodologies we currently support, there's the RMS from New South Wales, the Vic Roads from Victoria, and the TMR from Queensland. So I'll open up this asset here, Deterioration Culvert, and I'll demonstrate some of the inspection options that we have in the software. So by default, with each structure asset in AssetAsyst, you get two types of inspections, a level 1 and a level 2. Now the level 1 inspection operates off a checklist. So you can see here, we have different checklists defined for the different methodologies, but it's just a matter of ticking boxes to say these particular items have been checked. If maintenance is required, then you can add a defect on this inspection.
Yeah, I guess it's fair to say, Adam, with that checklist, that's come out of the Vic Roads level 1 inspection procedure for the Vic Roads methodology. And we haven't tried to enhance that too much, other than if you found a defect on one of those level 1 inspections, you could then assign the defect to the relevant component, which would then link it through to a level 2 inspection later on. So that the work of the level 1 inspector is contributing to what a level 2 inspector would then go and see as well and observe, so that you don't duplicate into sort of separate approaches. So you've just gone through to a level 2 inspection in there, Adam?
Yes. So on the level 2 inspection, we have a component assessment tab, and that allows us to assess the units on this particular structure. So this is one that's been done previously. You can see that condition is rated on a scale of 1 to 4, and you can put multiple components into different conditions. So this component 61P, 70% is in condition 2, 10% is in condition 3, and 26% is in condition 4. You'll also notice that we've logged a defect on this component, which you can view down here. If we double click on that defect, that will open up.
Yeah, and so for each defect, you have a recommended repair type, a time frame to intervene with its GPS coordinates, and then once you do the works, you can actually nominate a condition that the component will go back to. And again, that's so that if you do predictive modelling later on, you can see the benefit of actually doing those works. We note also in there we have an estimated quantity for the repair and cost for it, which in a lot of the manuals don't actually request that to be part of the level 2 inspection. You're not forced to do it through the software, but you can. Which definitely helps asset owners then develop a program of works and understand whether a problem's just minor or major in nature. Yeah, and so if we were to go and re-inspect this structure, the software will bring through the past assessments if you wanted to. So under that component assessment tab, there's a button there to bring forward the assessments if you actually wanted to. So there's an import assessments. This inspection's been signed off, so that's currently grey at the moment. Adam, I think we're going to show what this would look like under mobile solutions. Top in the main heading, you can actually export out information to the tablet app. And so on that tablet app, we've coded an application to run on Android devices. So you could use it on your phone here, or we more often use it on a tablet, which is more like your A4 size page. We find that useful. So Adam's just created an emulator to show what the actual tablet looks like, but it's just so we can run it on the desktop and show you today how that functions.
So we have this menu option here to manage the inspector tablets, and this is our data transfer tool. You can see here the structures that we have in this database. There's a number of filters you can use, and you can choose which fields that you want to export to the device. So you can make it green, which will export it. You can make it red, which makes it a mandatory field in order for the inspection to be signed off. In this case, we haven't ticked any of these asset level fields to be exported, but that can be very useful if you want to do some data collection of your actual asset level data while you're in field. So if we go to the device emulator, so this is just a standard Android tablet. So if we open up the AssetAsyst Inspector app.
Excuse me, Adam. I just have another question. Asking whether the app's going to be available on Apple iPhone.
Yeah, so at the moment, Hamish, we're developing the Works Crew app, which by the end of the year will be made available for people to use both on Android devices or iPhones and Apple products. So I think coming with that, it'll start to unlock the door for the general inspection side of things. But for the moment, today, the devices we're using as we speak for Android, or you can actually go mobile with your laptop computer or any Windows based device. So maybe what we'll do, Adam, is once you show just a little bit more about what it looks like on the actual app, if we also just point out how you go mobile with AssetAsyst in general as well.
Absolutely. Yeah, so we only have one asset on this device at the moment. So we'll load that up.
Yeah, and so we've used this app to probably inspect about 5,000 structures by now out in the field across Australia. And so our engineers have been finding it really useful to quickly collect photos, GPS coordinates, make sure you don't miss data, sign it off and feed it back into the system. And so when we've done that data collection, we've done that with having a number of teams out in the field at the one time. And I know at the moment for one council client who's flood affected, we're doing over 200 inspections within 2 weeks, being this week and next week. So we've got teams out in the field doing that work as we speak using this application.
So you can see we've got the geometry here that was in AssetAsyst. We've also got geolocation, and there's a button here just to update the GPS coordinates based on the device GPS hardware. And we've brought through the photos from a previous inspection. So this shows us what the structure should look like, which can aid obviously in locating the structure and ensuring that we're inspecting the right one.
Yeah, and so the other thing is you can remove photos, take new photos, and you can choose whether you want to bring through past inspection information for your next inspection or come in with just the blank generic data. Okay. And then if we just quickly show, we can go through the inspection side, which is just showing more about collecting the condition on the 1 to 4 scale. I think if we have a look at the pre-existing defect, so you can have each defect can have photos brought in. Adam's just demonstrating there how the colour, if you haven't fully completed the assessment, it'll show up as red, but once you've completed it, it's turning to green. This is a past defect that we've decided to import through in the process, and so we can then update the details of that, or if it's been treated, we could close that off as well. And as I said, it supports multiple photos for the one defect, and obviously multiple photos and other attachments at the asset level. And just in the interest of time, if we just have a quick, if you just go up to that mobile menu again and just point out, we have a download to mobile and an upload to server. So if we were taking a laptop out in the field, we can load to mobile and complete the inspection in much the way Adam's been demonstrating just before through the AssetAsyst interface. And when we come back from the field, we dock the computer, and next time we log on to AssetAsyst, it will automatically detect the changes being made and asks if you want to upload them into the main database. So moving on from that, if we have a look at a couple of reports, Adam, that we might get out of the system. At the moment, this reports menu, we're still doing some work on it, and there's a few things, versions or changes from the current version that most of our clients are using to this version that we're running today for the demo. We're continuously improving the software, and we use it ourselves first before it gets released on to clients to use. So So the reports menu in the next release will look different again to even what it's looking like today. We're streamlining it. So Adam here has gone to export inspection report information. And so we offer a variety of ways to do that. One of them is a Word document that some people find useful. So here we've exported it for an asset and it'll generate the table of contents, and then it'll start inserting information regarding the generic aspects of a structure. And then later on, it looks into that condition rating, and then any defects that have come up and the description about the defect and the repair treatments that have been put into the system are listed. So there's this Word report. Another format we find useful at a network-wide level is an Excel export. And in this one, we're able to get out photos and generic data and inspection data for a whole network of assets, and then filter that and use it in any way we please. So, and it might just show the spreadsheet that's generated from that. It takes just a little bit as it exports out the photos. Here, we've only done the export for one structure, but if you imagine having, say, 200 structures in there, you can then start to filter by year of construction or other things like that. And then there's hyperlinks to any photos that have been taken against that asset. When you click on the hyperlinks, the photos will then just upload. So you'll notice down the bottom of Adam's screen there has got generic tab. The next tab across is summary structure condition information, and the third tab across is generic information. Again, if we had many culverts, we could then filter this by using the filters at the top. If something was in condition 3, let's bring those up to the top and have a look at those issues first. Likewise, with the defects tab, you can then sort by priority of repair or urgency of treatment, and then you can sort by types and things like that. And likewise, over the very right-hand side, again, we have links to the photos. So if you imagine you're a works manager and you've got a whole lot of inspections that have just been done and you want to mine into that all at once, this export's quite a handy tool just to get your head around what defects have been collected, have a bit of a look at the photos, and it doesn't require any advanced sort of usage of the software. But with that in mind, we might just look now that we've sort of found some defects and things, how we'd go about treating those defects. There's two basic or two ways of scheduling works in the system. One via a basic work order and one via an advanced work order. So the basic work order is more about doing reactive works, finding existing defects and putting them onto a work order to be treated. While the advanced work order can be about being reactive, but is more about being proactive in works and scheduling reoccurring works or works that you want done in the future, such as maintenance work or preventative works to prevent defects from occurring. What we'll do now, Adam, if we can, we'll just show an example of adding a defect from an inspection into a basic work order, and then we'll have a quick look at the advanced work order. While Adam's doing that, another thing you notice, we've got the local government boundary map of Australia up on the screen there, but you can bring in any GIS layers you want, and you can link the database information to those layers so that you can search through on a map and click on a bridge of interest and it'll load up the data for that. Or if you're searching for a bridge, it'll then highlight where it is on the map as well. So Adam's gone into the basic work order screen there, and I think you've created that for asset type road. I don't know, have you entered in any road defects?
Well picked, Andrew.
Yeah, so again, because it handles various types of assets, when you create the work order's geared at a particular type. So Adam's now just typing in a name for the work order, and you can assign it to people there. At the moment, we've just set up as just one admin user, but under the tools menu, you can add in as many different types of people as you want, and you can give them permission to which parts of the software they're allowed to interact with or not. And depending on what role you tick for them, it will depend on what parts of the software are available for them to use.
We're just adding a defect into this basic work order now. So as Andrew explained, the basic work order allows you to specify a discrete list of defects that you want to resolve at that time. Now this allows you to close the defects directly from this screen, and if you have multiples you can multi-select and then bulk close them using these buttons here to close and reopen.
Yeah, and with the basic work order, any works on that you can select as being either maintenance or capital in nature, and that will flow through to the predictive modelling and the ability to then report on what your maintenance program is and your capital replacement program for your forecasting and budgeting purposes. So we're often using that for when we're creating 10-year asset management plans in accordance with the International Infrastructure Management Manual type framework and other similar frameworks. So Adam, could you show an advanced work order now, please?
Mm-hmm.
Yeah, so Adam's put in something here, painting, because you might want to schedule painting of an element that today is in reasonable condition, but you know the paint system might only last 20 years or so. And so in this case here, you can select what the element is that you want to paint. So Adam's just done a search for the elements and he's looking for the Sydney Harbour Bridge, and he's found there's a component called protective coatings. So if we go and select that, it'll bring up the quantity that's been put in there for that, and then we can choose whether it's maintenance or capital. If there was an existing defect and someone had scheduled a cost to repair it, that would have come through on the existing defect cost estimate there. In this case, we hadn't entered a defect for it, and so we're just forecasting a cost for painting. And then once we've done the painting, we might say that it'll bring it back to new condition, that paint. And so the other thing we had there, Adam, on the details tab, going back one, you could actually, there's a reoccurring box down the bottom. And so we could tick that and say, well, this is an iconic bridge. We need to keep on painting it, and we need to do it every so many years or months, etc., so that we can extend the life of the actual asset. And so you can put that into it, and then later on when we're reporting on our capital and maintenance expenditure, we'll see those costs flowing through, as well as the effect on the condition of the structure. The other thing, just while we're on an advanced work order, Adam, was the ability to choose defect types. We don't have a lot of data in this particular example here, but you can add a defect type if you had wanted to, and it'll then look on those components you've chosen for that type of defect, and if it's found, it will automatically schedule into an advanced work order. So this is quite helpful for certain types of maybe road approach defects and things like that that might occur relatively regularly but be treated through a program of grading gravel roads or things like that, that you can find those, put them on that type of work order and then have them closed out periodically. The other thing there, we have a defects export on that tab. I don't know, Adam, did you want to show how you can export out a layer to...
Yep.
So
we can export to 3 different formats here, KML and KMZ are Google Earth formats, and GPX is a popular format with car navigation devices. The idea being here that we want to give something tangible to the works crew so they know what defects that they are going to resolve. Now this GPS export is one way. You can also generate an Excel file which will just list the defects. But you can see an example here. Here's this defect that we just added to the basic work order earlier. And this is just embedded on Google Earth, and you can see exactly where it is. And you can bring up some additional information here about that defect. So this can be quite useful if you've got a whole bunch of defects in an area. The works crews can see them visually. And,
yeah, we've been finding that quite handy to share with people who aren't as familiar with the software. Those who are observant would have noticed that in the background on that map, we've got a cross has appeared, which is when a defect is being allocated to a work order, it'll then show it as a cross, showing that it's going to be closed out by the work order. So within AssetAsyst, the GIS interface is showing that information, but some people will just prefer to use things off their desktop, particularly if you're a works crew, or even if you're an infrequent user. It's a good way of sharing that with someone who's more familiar with things like Google Earth. Okay, so from that, we wanted to cover a little bit about the actual predictive modelling that we've spoken about so far. So we had that whole sort of asset life cycle of how to create an asset. We spoke about the different methodologies that are supported, entered in some component data, entered in a bit of inspection data. We've produced inspection reports, etc., and then we've scheduled works. So the next thing is to actually look to the future and see what this all means about how we're managing an asset and what the future condition of it will be like, to know whether we're doing the right treatments. And so to do this, we're feeding in condition information. Financial data is coming off the financial tab that we clicked on much earlier in the presentation. We've just done works. We need an idea about how much it's going to cost to replace the asset and what we want to replace it with. And there's a box for that on the financial tabs. And then obviously the generic information. Adam, do you just want to take us to, I think that culvert that we had in there, and we had some components? Yeah, so on this units tab here, we've proportioned the overall value of the asset to each of the components. The year of construction's come through from the generic information that can be overwritten, and there's been some default estimated lives for each component come through at this stage. And so, Adam, could you just click on the financial tab to show where the current cost information is coming from? Yeah, so in the current cost there, it's getting that value and it's proportioning it to each of the components. And so if going back to the units again, you'll see that we've got percentage allocations, and they can be altered at each individual asset and component level, and then redistributed back out. So hitting that current cost buttons and reallocated the percentages to bring them in line with more or less 100% and then allocating the costs out. So once you've done all that, you can choose a deterioration curve for each individual component, and those curves are set up in the tools menu. Going from here, once you've got all the data, you run the predictive modelling module. And Adam, were you going to show that process?
So we have the predictive modelling wizard here. We choose the assets that we want to show up on this particular model. In this case, we're going to use the deteriorated culvert. So I'll just add that to the collection. AssetAsyst does some validation. It finds that this culvert is ready for modelling, and then it processes that and produces the data.
Yeah, and so we've done that in a way that you can run the data for a whole network of assets. And so we've done that for a number of clients, process that data. And so then it produces a summary report. And in this case, it itemises those values that we saw lower down there. Adam, if you scroll down the structure components a little bit. Yeah, so it's itemised each of the components, what condition they were last found in, what the value of them was from the originally before they were deteriorated, and what the deteriorated value of those components are now. It's also got intervention levels, and so you can put in the tools menu, you can put for each and every component what condition you as an asset owner are happy to have those components in. And what this output is saying that for those box culverts where there's 20% in condition 4, that's actually past the point of when we'd expect to intervene, and therefore there's 0 years to intervention. The functional limit's the point at where the structures actually would be seen to be at collapse. And again, you can alter these as you see fit in the tools menu, and then the softwares will use that information to produce the results. So up above, we're plotting a graph for the next 10 years of where that structure is going with no works. And if we had to put works in there for it, the expenditure would show, as well as how it changes the condition. In some of the tabs of the worksheets there, we then produce the data for the next 100 years. And while we're working on the reports, at the moment we're working on producing 100-year summary reports, so people don't have to filter through the data to get the answers thereafter, and that'll do that at a network level. Whereas at the moment, users are summing up for all their assets across the rows of those tables to produce graphs about their overall network values. We're just streamlining that at the moment. Very good. So I'll just say we wanted to talk just next about what other things we're going to be working on, and I still welcome, if anyone wants to ask a question, you can either unmute your microphone, or if you hover down the bottom centre part of your screen, there's a little chat symbol, and if you click on that, you can actually type in a question. So I noticed we do have one there. Interested in how load rating is calculated. So, Adam, can we just go to the load rating tab just to show what's in there at the moment? So at the moment in here, we have a spot to record what we believe the load capacity of the asset is, and you can modify these drop-down fields here. In this database, we've got it set up for the different types of standard design loads that were around, and so you can choose for this asset what you believe it's been designed to, the year you've determined it, and then the methodology. Adam, if you click on that side of it, the methodology, you can then have a statement about what it's been based on. So whether you've guessed or the year of construction, etc. So in answering the question about how's it calculated, at the moment the software isn't auto-calculating capacities, or it hasn't got capacity curves in there. But we've been talking to one of the state road authorities about putting that type of functionality in it, because people are getting requests both from a state level as well as local government level for heavy vehicle permitting. And so one of the things we were going to talk about, I think, on what's next there, Adam, on the PowerPoint slides, was looking at the heavy vehicle route assessment. And so I think, yep.
Were you answering the question there about the deterioration curve, or is that a separate question really?
I was answering the first one, which was about load rating calculated, and I'll move on to the deterioration one next.
Yeah, okay.
So just with the what we've done in the past on load capacity, we've written codes. In this case, we're just showing some screen grabs out of our user manual for a load assessment tool we developed for a rail asset owner. And in that, you can input your axle spacing and masses for the different vehicles. In their case, they call them train consists. So you can put a range of locomotives and wagons together and run those over your assets and see what load effects they cause compared to a known design load, to see whether they would overload the asset or not. So what we're wanting to do coming up is to use the sort of smarts that we put into that system, but put that into AssetAsyst, so that you'll be able to put in a heavy vehicle application request, the axle spacings and masses, and then have the software then check whether a structure can pass that particular vehicle or not. And so we've got all the mechanics of it nutted out, and it's just a matter of time now to implement into the software. And hopefully that answers that question about how is the load rating calculated. So at the moment, it's calculated by engineers and just recorded in the software. In the future, it will be information from engineers and asset owners will be put in, and based on that level of information, the software will make some decisions about whether a certain vehicle would be suitable to pass or not. And that still may end up in a situation where engineer would then be asked to provide further comment or refinement. Yeah. So the next one I see, there was a question, I was wondering about the deterioration curves are based on. One of the things there, the deterioration curves can be based on a number of different things. So the most common one is by plotting data and putting lines of best fit through that data. And so Adam, can you bring back up the software where we've got the curves in it, just to show what that looks like? One thing we're looking at with the reporting is, Hamish is actually coding this up at the moment, is another report where we'll put out for a particular component its age versus its condition. And so that what that'll allow asset owners to do is, for their very own network, get the data out and put a line of best fit through it. You can then copy that data out of Excel or whatever other package you want and paste that into this part of the software where we have curves. So you can add your own curve for any particular component or object you want, and then you can use that. So that's one way of doing it. Another more scientific way of doing it is you can take, say, for a concrete component, test for carbonation, chlorides, etc., and then from that you can actually forecast how much more life is left in an asset. And this is where we're interested in working with asset owners who want to go from less scientific means to more scientific means. And by that I mean applying testing to structures which has a direct relationship to their how long they're going to last and scientifically proven, rather than by observing deterioration to then use that as an indicator of what's going on. Because often by the time you observe something, it can be too late, and using just your eyes to understand the depth of chlorides is not the right way if that's the mechanism that's leading to deterioration of your concrete, and therefore corrosion of the steel reinforcement. By the time you observe it, it'll be too late. That gets to the third way at the moment, which is rather than fitting data to points and perhaps using the wrong cause and effect for it, saying that observation can forecast it, which could be the wrong premise, we can actually use our engineering judgment about a design standard saying something will last a certain amount of time, and then using that knowledge of how long code would say it should last in that condition to then what our understanding of what condition we see it move through to over time, basically. So I've probably been a little bit unclear with that, but there's a fair bit to explain without diagrams, etc. Had another question come in regarding the way you create the intervention criteria. Yeah, so again, intervention criteria. Adam, can we go to the tools menu and component material relationship? Might take a little bit just to load that menu up because it's got quite a bit of information in it. But what we do in there, we actually set the intervention criteria there. And what we've said for Bridge and Culvert asset owners is what condition state, how much of a structure would you be happy to have in condition state 3 or condition state 4? And so it more comes down to a level of service issue for you as asset owners. Do you want to see spalling and defects, or do you want to see no defects? So Adam's just gone to this relationship. So you see there's a column called intervention level. And so we're saying for a component 1P, at the moment we've typed in an intervention level of 25, but Adam, you could change that to we're happy to have 50% in condition 3 before we'd intervene. So the end user decides what intervention level, and that'll come down to your asset management plan. And it's all about levels of service. Do you want to see chunks of concrete falling off? Do you want to see gross corrosion, etc., or not? There's still an issue about risk. So what risk does it present if we have these things in poor condition as well? And that might be the thing that will prevent you from wanting to say, let's have really intervention levels that need a huge percentage state to be defective. We've also set the functional limit there, which is that last column. So what percentage are you happy to have in condition state 4? If you remember back to the example that we used earlier in the presentation, that culvert had not yet reached its functional limit. It's still in service today, but it's past the point of when you would have normally liked to intervene according to the criteria that we'd put in here, which kind of makes sense. You don't really want to see a whole lot of corroded reinforcement and then try and fix it. You want to get in before then if you can. But once it's there, does it mean that the structure can't be used anymore? Well, not necessarily. And that'll depend on what limit you want to use for it. Hopefully that's answered that question. How did we derive the deterioration curves in this example? I believe in this example here, we've chosen to use, I think we had a straight line and we had a curve. So it was relatively random for this example that we're doing today, because this is just demo data. And what we'd prefer to do is, if we're doing the work, is work with individual clients to set data up that meets their needs. And as a demo, we're not we haven't organised permission from particular people to use their data. So say if it was Vic Roads, and we've done work in the past, we can plot a range of data that is available there in the way I said before, and fit lines through. And then we can apply those lines directly back into the software. So I think that was it so far on those questions. Happy to take any more questions. We put in the invite that things would start at 2, and we didn't put a finish time, but we'd intended to go for about an hour, because we realise after that it can be somewhat tiresome to listen further. I think, Adam, just on what's next, we had a couple of other items listed there. One of those was, if we go just back up to the previous slide, bridge barrier assessment. This is something that we've done quite successfully outside of the software in the past, but we're going to apply in the software. And so we're planning on presenting more on that at the Australian Bridge Conference. I just had accepted today the ability to do an oral presentation on network-wide barrier assessment. And so at the start of next year, I'll outline a methodology for doing that, but we hope to apply that intellect into AssetAsyst, so others can benefit from it. And do network-wide barrier assessments. Because I know even recently in the news in Victoria, there was a person, I think, severely injured, if not almost killed, from running into the end of a barrier recently, and we've had many other cases like it. So barriers can save lives, but inappropriate ones can also obviously not do the same. So that's one area that we're pretty passionate about. The other one that I've listed there was optimization algorithms. So we've come up with a way of looking at what the future condition of assets are like. And so the next thing we'd like to do is marry that with what we've done in the area of risk assessment. And we have a risk scoring procedure that we've had for 10 to 15 years. But we're looking at combining the risk scoring with the predictive modelling to then help asset owners choose what works they might do and the benefit of them from a risk point of view as well as a monetary point of view. So at the moment, when you do works, you can alter the condition through the predictive modelling, and you can see how when you spend a certain number of dollars, what benefit you get from doing that expenditure, but we'll also show what risk reduction you might be providing. And then you'll be able to make a choice as an asset owner, and pitt&sherry, working on behalf of asset owners, will also be able to make informed choices about whether in doing works, what effect you've had to reduce risk, as well as the direct financial benefit. So they're the 3 key areas that we're looking at for the future works. So unless there's any other questions, what we might do is call the session to an end, and just encourage, thank you firstly for participating on the session. It was much appreciated for those that could attend. For those who have any follow-up questions, more than welcome emails from yourselves or phone calls. More than happy to discuss any points to query, and then obviously always keen to visit people for one-on-one conversations as required. So I hope you found it useful, and I'd like to thank also Adam and Hamish for their contribution.